Good morning. I'm Martijn Walraven. I work as an open source developer at Meteor on Apollo. And I've been working mostly on an iOS Swift client for GraphQL. This is part of our sort of open source Apollo client project. So we really see this as sort of a family of GraphQL clients with, as much as possible, sort of similar design, definitely a similar design philosophy. I'm really excited to sort of be sharing this stage with Ben Schwab, who's an Android developer on the native infrastructure team at Airbnb. And he's been an active contributor on the Apollo Android client. And I think this is probably the first time that we're actually talking about the Apollo Android client. So I think it's a great example of sort of the community-driven nature of the Apollo projects. As Ben will explain, there's like a group of active developers who've been really building and designing this together. And at the same time, we've been able to share a lot of the design from well, both the JavaScript client and the iOS client. So as a sort of background, and this is a story that may be familiar to some of you, or to a lot of you maybe. This is the Facebook app, like sort of fall 2012. This was the first native version of the sort of modern Facebook app. And this was also the first app that actually used GraphQL. So GraphQL was developed in the context of sort of the redesign of the Facebook app. So even though, like most of you probably heard of GraphQL for the first time about 2 years ago, when people inside Facebook started talking about GraphQL, open sourced the spec and the Relay client, GraphQL had been in use at that point for quite a few years, and like right now, it's been almost 5 years. Like I think most of the people in this room have used the app. Like literally hundreds of millions of people have been using GraphQL over the last 5 years. So one of the interesting things about sort of the history of GraphQL is that it was developed really to solve problems with mobile apps, like really designing the best API for mobile apps. But also that it was designed in the context of a very practical project. So this was a project where like the product team and the people that came up with GraphQL really worked together. So the question they asked themselves was, what would an ideal API for mobile apps look like? And what's interesting looking back is that sort of the ideal API for mobile apps is very similar to the ideal API for web apps nowadays. So a lot of the problems that they were trying to solve for mobile apps are very similar to the problems people run into with mobile apps nowadays. Because a lot more sort of component-oriented and client-side processing happens in modern sort of interactive web apps. So we're all familiar with sort of the basic promise of GraphQL. Like, what does it really have to offer? Well, it allows clients to not rely on the server, exposing endpoints, giving you sort of data that you may not actually need for a certain screen, but it really allows you to specify the exact data needs. So you have your schema on the server, you write your queries on the client, and you get the exact data you want. So this is like a pretty big benefit for mobile apps. You only get the data you need, so that means you use less bandwidth, less processing. It also makes it easier to evolve your apps, to have multiple versions of your app running in parallel. But I want to make it sort of clear that I don't think GraphQL is just about performance. So one of the big benefits of GraphQL, and I think that really shows sort of the development process, like how it was developed as part of a concrete project, is that GraphQL has been designed from the start to really care about developer experience, to really think carefully sort of what a good developer experience looks like. And sort of the best example of that, and I still think, I mean, this is probably something most people show when they want to explain GraphQL, rather than sort of try to explain what GraphQL is. Just showing people graphical is a very good way of sort of showing the benefits of GraphQL. And that brings me to sort of one of the first design principles of the mobile clients. That's don't try to hide GraphQL. So GraphQL is a really well-designed language. It's pretty easy to learn. There's a lot of tooling around it, like graphical. And especially in the early days, I think, a lot of people who started to think about sort of native clients for GraphQL, their first approach was to build something like a query builder. So they didn't want to sort of have to deal with strings. They perceived GraphQL as a string, and instead they developed something like a query builder. So you could use Swift or Java to basically construct a query, and then you'd get a string back. So this has a couple of drawbacks. One is I actually think GraphQL is much more readable, but there are more sort of there are additional drawbacks. One is that this kind of query building is dynamic. It's something that happens at runtime. So that makes it difficult to analyze your queries at compile or build time. And the kind of statically analyzable queries that you get from, for instance, storing your GraphQL queries in a separate .graphql file is that you get additional features. And persisted queries is something you may have heard of. It's also a pretty nice feature for mobile. It basically allows you to, instead of sending the full query with every request, like in advance, upload your queries to the server and identify your queries by an ID. So at runtime, you only send an ID to the server. You don't have to send the full query. That means you're using less bandwidth, but it's also a potential security feature because you can whitelist queries. Like clients can no longer perform sort of arbitrary queries against your server. So these are other sort of benefits of static queries. But I think from the perspective of developer experience, it's also sort of like as soon as you start looking at tooling, as soon as you have sort of the ability of treating GraphQL as more than just a text string, you start getting these benefits in the experience. So for instance, you can get integrated validation of your queries. I'll show an example of this later. And there are some exciting developments here as well. So Yo, who worked at the, who's part of the GraphQL team at Facebook, he's one of the authors of Graphical, is working on a GraphQL language service, which sort of extracts the diagnostics and auto-completion from Graphical into a separate library that runs on your machine in a process, and that can be used by different front ends, IDEs, and other tooling. So there are a lot of potential ways of sort of benefiting from treating GraphQL as its own language, building shared tooling around it. But let's look at how you would actually sort of use GraphQL in your app. So you have a query. You can get data out of it. That's what you get when you run your query in Graphical. But how do you actually do this at runtime? Well, as Jonas also explained, the simplest way of using GraphQL is simply to treat it as any other HTTP request. So you use curl or sort of any HTTP library in your native language to execute the query, and you get back a JSON string, basically. And then, for instance, in Swift, you would use the built-in JSON serialization to convert that string of JSON into sort of untyped objects, dictionaries, arrays. And it's pretty painful to have to deal with JSON in this way, especially in a statically typed language like Swift or Java. So you have all these sort of dynamic casts, all these type conversions, all these sort of potential potential runtime failures. You have to deal with missing data yourself. So it's a pretty painful process. And I mean, this is similar to what people who use REST APIs have to deal with. And the most common solution is to write some kind of model layer. So instead of dealing with sort of your untyped JSON at runtime, you write models that contain properties, and then you either manually or by using some kind of framework convert the JSON into those models. And that works. Like, the development experience is a lot nicer, but you're doing a lot of extra work here. So you have your models on the server, but you also have to write that entire model layer on the client. And with GraphQL, we of course have something pretty amazing. We have like a fully typed contract between the client and the server. We have a schema. So what you may want to do is, instead of writing these model objects by hand, you can actually generate them from your GraphQL schema. So instead of writing a post struct with all these properties, you simply take your GraphQL schema and you run a code generation tool, and then you would get these type models. So that gives you a similar experience to what people are used to with REST, but with a lot of automation. You no longer have these sort of duplicate model definitions. But there is a pretty big drawback here. We're not taking sort of full advantage of what GraphQL gives you, because GraphQL doesn't just have a schema. The schema represents the capabilities. It represents sort of what data you can potentially ask for. But in a specific query, you actually have to specify the exact data you want. And so you know in advance what data you'll get back. And it's very inconvenient to sort of have to deal with large model objects with a lot of properties that may not be filled from particular queries. So every property is potentially null, for instance. So what we do with the Apollo clients, both the Swift client and the Android client, is we actually generate models from queries. So not from schemas, but from queries. And the types you get are specific to the query. So there's no sort of global post object or a global author. There's the post that you get when you execute this specific query. And that post has a title, it has an author, that author has a first name, but it doesn't have a last name, for instance. And this gives you a really nice experience of sort of static type safety, all the way from your server to your UI. So I'd like to give a short demo of what that would look like on iOS in Xcode. So this is Xcode has the concept of a companion view. So it shows, in this case, a Swift file and a GraphQL file sort of side by side. This is the query, the all posts query, that generates a Swift class, the all post query class. We can use that to execute the query, and we get back results. And these results are fully typed. So in this case, it's an array of post objects. We can then use those post objects. Let me quickly show you what the app looks like. This is a simple sort of list view, table view, posts with titles, authors, and the number of votes. So we in this case, use the post details fragment to configure the cell. And if we look at the cell, and as you can see, the sort of corresponding GraphQL changes automatically. So you always work side by side with your Swift and your GraphQL. So here you actually deal with a post details object. And this is fully typed. So you get code completion. But also if I, for instance, remove the title field from this query, I now get a compile time error because this model object no longer has that field. So you can be assured sort of at compile time that the data you use to construct your UI is actually data that's requested from your server. And then the nice thing about this integration is that it also works sort of the other way around. So you get full like GraphQL validation inside your IDE. We're working on a similar experience for Android based on the GraphQL language service. This is not as mature right now, so it's really work in progress. But it should offer some of the same experiences, like a validation error, for instance. But one of the benefits of Android Studio, or like really the JetBrains platform that it's based on, is that it's much more extendable. Xcode is pretty closed. So we should be able to get auto-completion and all kinds of other nice features in here as well. And with that, let me start the next presentation. And yeah.
Awesome. So my name is Ben. I'm a contributor on the Apollo Android project and work on the native infrastructure team at Airbnb. Just to start off, could I have a quick show of hands of how many mobile developers we have in the audience today? Okay, a couple. Cool. First, I want to give a really quick history of GraphQL at Airbnb. So back in 2015, our foundation team started experimenting with a way to write GraphQL-compliant Rails APIs. And we started using this internally for services at Airbnb. But we didn't really take a look at using this for clients until Q4 of 2016. And finally, today, we're getting ready to ship our first client feature written in GraphQL. But before we could get there, we had to answer an important question. Which GraphQL client should we use? Should we use Relay? Apollo? Maybe we should roll our own. So we sat down and we sort of wrote down a bunch of requirements of something we'd want to see in the GraphQL client we chose. One of them was that we wanted GraphQL to be a first priority feature in the client for many of the reasons that Martin just explained. One of the biggest ones, though, is we wanted something that was unified across iOS, Android, web, and React Native. And this is because at Airbnb, our mobile apps have some features written in React Native. So we have developers that are switching from potentially Android, iOS, and JavaScript context, and having a unified architecture is important. But not only that, there's actually some possibility to share code across the clients, particularly with the cache. I'll be getting into that a bit more later today. And finally, we want something that was extensible. Would we be able to control where our cache data was stored? Would this client be able to grow with us? So, spoiler alert, we ended up choosing Apollo. But it turned out when I took a look, there was this Apollo Android project back in the October timeframe, but it had just one commit that was like work in progress, maybe like a README with one thing in it. But what was really awesome is the community really came together, and in the last few months, you can see a ton of activity on this client. And we have contributors from Shopify, New York Times, and Airbnb. And to give you an idea of the level of commitment of these contributors, we got this message from Ivan a couple days ago. And he was just letting us know that he was going to be a little bit slower reviewing his PRs because he just had a baby boy. I don't know how true this was. He's still reviewing PRs really fast. He's still putting up a lot of code. I guess he's using his sleepless nights with that, but he's a great guy. So what I wanted to focus on today is how I see using Apollo and GraphQL to build context-responsive apps. Context is sort of an overloaded term, but I think the best way to understand this is with an example. So say I want to build Git Hunt. This is sort of a prototypical example for GraphQL. It's just a mashup of GitHub and Product Hunt. So pretty much a way for you to find new repositories and vote on them. So these are the mocks that we're building, and we see there's a couple really awesome repositories available related to GraphQL. This looks pretty easy, right? So let's build it. But let's remember that mobile app constraints. You're going to be frequently dealing with inconsistent and slow networks. To just prove this point, this is me clicking into one of the detail pages on a client that doesn't have any caching. And this might look like it's just looping, but it's not looping. This is actually me clicking multiple times and watching it load over and over again. Similarly, there's a lot of people with old devices that don't have much memory. And this is important with the last constraint, which is you're going to be running in a lot of variable contexts. Apps need to be able to handle rotations, which might load a different layout. Because there's low memory on mobile phones, the operating system might actually come and kill your app, even if the user just backgrounded it for a few seconds. But users expect, when they come back, to have all the information fast and ready. So what can we do to create context responsiveness? The simple answer is caching. When you're showing data, show cache data first. When a user rotates their device, show cache data. If your app was killed from memory restrictions and a user comes back, show cache data. So this sounds pretty easy, but it's not that easy. So in the REST world, the easiest thing that you could try to do is something just called response caching. Just take the response, cache it, and maybe you're good to go. But what happens if you're watching this example is I go to upvote something, and I go back to the previous page, and since these two pages have two different responses, and these responses are separately cached, the upvote action I performed is not reflected when I go back on the first page. And this is a big problem. To really nail home why this is happening again, you can see this is the JSON response on the first page. It has this vote value. I go to the next page and I upvote, but I come back to the first page. It's the old cached JSON response with 0. So what can we do? Well, a really good answer is response normalization. I know we talked a little bit about this already today, but I'll go over real quick what that means. So the idea is that in a response, every object that you see is going to be a record. Every scalar value of an object is just going to be a field. So what you see right now is I have multiple GraphQL queries, all of them referencing a repository. All their fields are going to be merged together if they're scalar values. But when we get to something interesting, I'll come back to that, such as this vote object, we're actually going to take that and store it as a new record, but in the record that contains this as a reference, we'll just have a cache reference, and this will allow us to trace it down. The last little nuance is every single record needs to be signed an ID. Often this could actually be an ID property on the object, but sometimes your object might have something else that acts as an ID, such as the repository's full name. OK, so without GraphQL, what would you do if you wanted to build response normalization? Well, it's really complicated. The networking libraries that ship on mobile clients don't do this for you. They would have no way to do it is the problem. So developers would have to write by hand some sort of bridge between a persistent technology like SQL or Parsable or an ORM. And this is, in my mind, a really big problem because it leads to code bifurcation. What this means is your app has two different ways to load code, whether or not you're loading from cache and from network, and this is going to be a cause of a lot of bugs. But with Apollo, a lot of these problems are fixed. It's really simple. There's very little work you need to do as a developer to enable normalization. And this is because the GraphQL schema and awareness of that helps out a lot. And there's very, very little code bifurcation. Really, the only difference is this tiny little snippet right here that I've highlighted, which is when we're reading from the cache, we have a reader that checks to see if string fields are of a cache reference type, and then it just follows that reference as it's reading. So very, very small differences between the two code paths. So let's take a look at what it's actually like to set up a cache on the Android client. And there's some interesting things to note. So you see that we're creating a normalized cache, but the type of this cache is an LRU normalized cache. This is important because remember, one of the constraints of mobile development is that you're running with very little memory. So an LRU cache will evict records if you're running low on memory and based on a least recently used basis. But even if you evict something from memory, you probably have more persistent memory available to use on the mobile device. So we can back the LRU cache with a SQL cache. And the memory cache will read through to the SQL cache if the record is not present. And this is all the code you need to do to set it up. As Jonas was mentioning, there is a few other things that you do have to do. And one of the important things is specifying what the ID of your object is. So we have a very similar concept on the Android client. We call it a cache key resolver. So typically, this will just be you grabbing the type name and the ID from the JSON and using that as a key. But in the example I went through earlier, the repository actually wanted to use its full name as a key. So you just have to write this little code snippet right there. So one thing I just want to call out that was very intentional in our design was we wanted to make it very easy for any mobile developer to write their own implementation of a normalized cache. So maybe you're not happy with our choice to store in SQL. All you need to do is implement these methods, which is essentially just a key value store for records. However, what we do for you is we wrap the normalized cache in an Apollo store. And this is going to give you thread-safe access, backed by a read-write lock, and subscription management if people are watching queries. And as Jonas also mentioned, one great thing is that this sort of architecture pattern is either very similar or will be very similar across all platforms. So this is the really cool thing I'm excited about is let's say this example app that we're building had an additional requirement that the feed page was going to be built in React Native with JavaScript, and the detail page was going to be built in Java. Even if we use response normalization, we're going to see the same exact loading error of that video that I showed you, because traditionally, JavaScript and Java would not be able to share a cache. But because we've standardized on the cache format, we can actually write a React Native bridge that exposes the same Apollo store to the JavaScript client and Java, and you get all the benefits of caching, even across React Native and native. So to show you, with Apollo, you can see I rotate my phone, saw no reloading because it loaded from cache. I go vote. You see the upvote reflected there. I go back, and it's reflected in the app. And the great thing is, I'll go over this quick because I know there's not a lot of Java developers, but this took very, very little code. All I had to do was create the call. I specify how I want to load the data. So with the feed, I might want to actually not show cache data at first, and instead rely on the network and fall back to the cache if you're offline. But if I rotate the phone, I actually do want to go to cache first. And all you see right here, that's the only difference of the two pieces of code. So this enables a unidirectional data flow, which is very hard to get on mobile because of all the different situations that you're trying to handle. But now we can have just one data callback that's going to be setting our view in one location, and it's going to be aware of the loading state. So we can do cool things to sort of tell the user what state their app is in. So what that might look like is, maybe we do want to show cache data for the feed. So while it's in the cache state and we're still fetching from the network, we'll gray it out so that the user has an idea that it's cached. When it comes back, we remove the opacity. But if it turns out they're offline, we'll remove the opacity, but we'll also put a little banner at the bottom of the screen telling the user that they're offline. And this is all just really easy to do with Apollo because your loading state is tied in with your data model. The Apollo Android client is ready to try today. You can check us out on GitHub. Really appreciate it if you join the Slack channel. Let us know additional features you'd like to see. And of course, there's a lot left to build, so more contributors would be welcome. Thank you.